Layer 3 switching can improve the speed and performance of your network by combining the functions of Layer 3 and Layer 4 with the speed and efficiency of Layer 2 frame switching. To better understand Layer 3 switching, we'll first look at inter-VLAN routing operation, then we'll look at traditional multi-layer switching, and then finally Layer 3 switching particularly. In traditional routing, you would have a router here and then two separate LANs here. Switch here, switch here. However, when we come to the concept of VLANs, we now take out the second actual physical link here and we break this up into the two separate LANs or the two separate broadcast domains. And in order to route between VLAN 10 and VLAN 20, we would have to send traffic over to this router and then back to that same switch in order to go to a device on VLAN 20. This is called inter-VLAN routing, where we're using a device, a router here, and that router is referred to as a router on a stick. That router on a stick is going to perform the inter-VLAN routing for us. However, we're still having to send packets out to this router every time we want to communicate between any device attached to this same switch. Multi-layer switching puts both of these functions into one box, or speeds this process by giving us a multi-layer switch engine, multi-layer switching switch engine, say for instance with the Catalyst 5500 in traditional multi-layer switching here. We would then put in a blade into that 5500. We would put in a module into that box that's going to provide us with the routing function. This is the multi-layer switching route processor. It's going to be a built-in or an installed blade into the same 5500, thus speeding the process of communication between the switching function and the routing function by using the gigabit plus backplane of a 5000 or 5500 switch. In multi-layer switching, what takes place now is, say for instance, device A is opening up a telnet session to device B. Notice the two of them are on two separate layer 3 networks. Device A sends the first packet. It hits the switch engine here, hits the switch. The switch sends that packet to the route processor, and the route processor then determines exactly what VLAN B is on and would send the packet back down to the switch. The switch establishes what's called a flow cache. So basically, it records the layer 2 information coming from this source MAC address going eventually to device B here. Coming from that source going to, so 10111 for the layer 3 source address, and then the 2111 going to that as a destination address. The switch records that information. After this packet has come back down, the router indicates which VLAN the packet will need to be sent out of, and now the switch knows which port exactly to send it out of, and so therefore the switch will associate that outgoing port. We'll say that's port 4, Ethernet 4 on the switch, and the switch then sends it out to device B. That's the first packet. All subsequent packets after that first packet can then be just compared directly to the entry here in the flow cache. And so now in multi-layer switching, traditional multi-layer switching, we have a route 1's switch many concept, route 1 switch many. However, this is still being done with two separate processors, a separate route processor, a separate switch engine. In layer 3 switching, all of this is going to be done with one common processor called Cisco Express Forwarding, And so now this 3550 switch, it keeps a MAC address table and a forwarding table. The forwarding table is sort of like this routing table or a flow cache. And the other table here, the MAC address table, still contains the MAC addresses. That way, all of this is being done with one process and one processor in the 3550, thus speeding the process along. So layer 3 switching is an improvement upon inter VLAN routing by speeding the process along of Route 1 switch many, as well as an improvement upon traditional multi-layer switching, which would have to use separate switch engine and a separate route processor.